Good morning. If you are looking for the Signify overview webinar, you are in the right place at the right time. My name is Jimmy Guerrero, and I will be your host for the next 30 minutes or so. And today I am joined by Signify CEO JP Marcos. And in this webinar, we're going to learn about Signify the company, how its machine intelligence platform can help your team achieve more uptime, as well as Signify's mission, plus a quick demo of the platform itself. And with that, I'm going to go ahead and mute my line.
Thanks a lot, Jimmy. I'm JP Marcos, the CEO and co-founder of Signify, and it's my pleasure to take you through the history of Signify, where we come from, the problem we're trying to solve, some of the things that we've learned in solving that problem. And then after a few slides, I'm going to switch to a demo. A little bit about us. So we are a team of tech ops engineers. We've been in technical operations for many years, running fairly large systems and data centers. And our world looked something like this. So we had become customers of a lot of great companies such as New Relic and Splunk. We had lots of open source tools as well, Nagios, Graphite, Grafana. And at any point in time, we felt really covered. Every part of the system was visible to us. We were able to track the health and behavior data of everything. But there were still a few problems. The first one is that at any point in time, we had thousands of data points. It was impossible to really track and make sense of everything. The second is that those tools are very specialized. And so every time we had an issue, we were frantically jumping from one tool to the next, try to piece together the relevant information for coming from the tools that were tracking different parts of the system. The other problem was that every single tool come with their own alerting capabilities. And so if you configure each and every one, at the end of the day, we had a glut of alerts coming to our phone. And the result was that we were always on the reactive side. Our downtime wasn't changing all that much because the process of gathering the data, of understanding what is the root cause, of really sifting through the noise was still a fairly cumbersome process, and it was mostly a reactive process. We decided to improve our operations and do something about it by coming up with some technology. The reason was that what was important to us were three things. The first one is obviously to increase uptime. And if it takes you a lot of time to fix issues, you're not really addressing downtime all that much. And if you're not able to be proactive, your mean time to failure stays the same. So we had to affect our mean time to remediation and mean time to failure in order to really affect system availability and uptime. The second is that we were involving a lot of people in fixing those problems. So we had war rooms, everybody gets together in the same room and then share information. I mean, you can imagine that the payroll cost of that process was not that great, and we certainly were not moving across issues very fast, and so we had to improve our process. And finally, as mentioned cost already, it was costing us a lot of money not to fix downtime, because during that time we were not generating revenue and our customers were not happy. And we also were just using a lot of people's time in essentially going through manual processes. So if we looked at the type of technologies that we have implemented, when we started, we really wanted to see what was going on. We implemented visualization and alerts tools. It's the previous slide that I just described. Then at some point when we're fixing issues, it was important for us to make sure that we captured the knowledge, the learnings, so that the next person wouldn't have to reinvent the wheel every single time. And so we implemented those tools and they're available. And sometimes, you can use tools like Slack or PagerDuty in order to do that. We were bombarded by alerts. And so we implemented also tools that were able to do alert aggregation. What we didn't find in the marketplace, we think, is the next step is really the automated answers. Like, it would be great if instead of having a lot of data on my lap, I would just get an answer. Like, you have this problem, this is the root cause, and this is what you need to do. It would be also very useful for me to be able to anticipate problems, to figure out that something is about to break. You're running out of memory somewhere, you need to upgrade this particular hardware, whatever it is. And that really wasn't in place. It would also be great if instead of having knowledge captured sitting on postmortems somewhere in your wiki, in runbooks, if that knowledge was able to be put in context automatically. So every time we had an issue, we would have to trigger a manual search to see if we had documented something previously that was useful for the particular issue, or we were doing search over the internet, see if there was some knowledge there that we could leverage. But what if all that knowledge was able to be put in front of you at the moment you need it? We think that that's probably something that the industry should tackle. And finally, we believe that everything that can be automated should be automated. There's a lot of manual tasks that are fairly mundane and repetitive on a daily basis. Things like rebooting a monitoring tool that doesn't work, or adding capacity. And everybody has a bunch of playbooks on top of Ansible or Chef or Puppet. Wouldn't it be great if we were able to set up the triggers for those playbooks, and if they would run in the background automatically, we would control when and what conditions would apply, but then we wouldn't have to deal with that directly. So the last four are essentially the basis of our vision. We think that the next step is to make the software that monitors environments a lot smarter by being able to make sense of the data and provide answers, not just on the diagnostic side, but try to anticipate problems before they arrive. If the knowledge that is captured in the process of fixing things would be correlated to current issues, so I can use it automatically. And then if I could control the type of task that I want to be done automatically, so that I can move on and do things that are of higher value to the company. Those are the four things that represent the basis for SignifAI. A few learnings. It took us a few years, yes, years, not months, to get it done. So a few things that we learned along the way, and principles that we follow. The first one is that there's not going to be an autonomous data center, meaning that you always going to have to put someone at the top, and the best you can do is provide leverage to someone. And there's a number of implications in that statement. The first one is in how you communicate to that person. I think it has to be easily digestible in natural language. It's very important. The second principle that we follow is that we need to break the silos of data. The previous slides shows that your application data is in somewhere, your logs are somewhere else, you have your network data somewhere else, your infrastructure data in another repository, and it's all silo. But it's very important to make sense of all of it, so we put it all in one place, and that's easier said than done, because there are obviously functional silos as well as technical silos. The data is of different nature. You have log data, time series data, events, but it was important for us to put it all together in one place and make sure that we are able to make sense of it no matter what type of data we collect. The next principle is that less is more. If I give someone 1,000 data points, that person is going to be actually a lot less effective than if I give 5 data points, but they're the right ones. They're both a high threshold in terms of importance. And so that's something that we apply. We try to give less data, and we try to make sure that it's extremely relevant. And we do that through a variety of techniques, including automated correlations, and predictive algorithms. The next learning is that the expert is in your company. You don't have a magic technology that's going to come from the outside, know better than you about what are your KPIs, what's your history, and will have more knowledge than all the knowledge that you've accumulated in your team, as well as in your playbooks, in your postmortems. So it's important to give a team the ability to transfer their knowledge fully without limitations to a system, to make sure that the framework of analysis that is applied is the same or consistent with that of the particular team. The next principle is that knowledge should work for you. You should give you leverage. Instead of being somewhere without and not being used automatically, it should be put in context the moment it becomes relevant to a relevant issue. And the last thing, as I mentioned, is that everybody has a lot of playbooks that are tried and true, that are low risk, and those playbooks should be put to use automatically. The one thing that cannot be done, though, is transfer those playbooks from one company to the next. We believe that that's when you break things, but at least being able to automate your own playbooks on top of a remote execution technology is something that can add a lot of value and save a lot of time. So with that said, I'm going to switch to a demo, and I'm just going to switch screens for a quick second. Okay, so we're now in the SignifAI version, and I skipped the onboarding process where you put your name, you answer a very quick questionnaire on your priorities as well as your external dependencies. And I want to show a few things very quickly. The first is how we get your data. The main thing that we wanted to achieve is to be able to get all your data, not just the data that you track, what is known, your events, but a lot more. We want to track the unknown, the things that you're not even tracking right now, that we know based on our expertise and experience is important. And we want to get that process done for your full system soup to nuts in 20 minutes. So how does that work, and how's that possible? So the first thing that you do is you just go through a list of integration points. These are monitoring tools that will give you a self-serving menu and where you should recognize the tools that you're currently using. So we're interested in your application, infrastructure, network, storage, collaboration, as well as notification channels. And let's say that you're on New Relic, for instance. So you select New Relic, and you do a couple of things. The first is you go to the collector URL, and here you're going to set up a webhook by copying and pasting this particular link into your JSON. It takes a few seconds, and once you've done that, then we have a webhook with you, and we track everything that you've set up to track in terms of metrics or logs or events automatically, and we collect that data every few seconds. The second thing that you're going to do is you're going to give us your API key so that we can do API calls and go back in history and have very quickly a baseline of behavior for your system. And we're not just going to track the metrics that you've set up to display to your team, but we're also going to generate additional events. We're only interested in health and behavior data of your system. So we don't track a lot of data. We only go after metadata, but we go a little bit deeper than what teams have set up to track typically. So that's for one sensor like New Relic, and it literally takes a minute. When you go to AWS, it's the same thing. You just go and set up a webhook. You copy and paste this particular link into your SNS, and that's it. If you need additional information, the process is documented here on the right. On the active inspector, we ask you for your account number, your role, external ID, and the main region that you're using, and that's it. And then we have the information that comes from CloudWatch and Redshift and everything that we can track in AWS, and so on and so forth. I'll give you another example. For instance, PagerDuty. So PagerDuty is a notification channel for us, as well as a source of information. So you set up a webhook here, copy and paste this, and then you give us the API key. And there's an additional step here to make sure that we use the PagerDuty as a notification channel as well. And it literally takes a minute or just a few minutes. So once you've done that, and typically since you have, let's say, between 1 to 10 integration tools, within 20 minutes you can be done. Let's say that there's something that we don't have yet on our list, and we have over 60 integration points, or you have something that you've built yourself. Not to worry, you essentially have the ability to push data to us through our REST API interface. I'm not going to go through the steps, but essentially you need to select the data that you want to push, the format in which you want to push it, the frequency. It's a little bit more involved, but that's pretty much it. And typically this is a 10 to 20% problem, meaning that you never track 100% of your data through something proprietary, but we have the ability to gather that data so we don't miss anything. So with that process, we are able to gather 100% of your system data, going from the metal, the infrastructure, all the way to the business KPIs. And it's a very, very fast process. Then you go to something that we call the control center. So the control center is where the action is and when you're going to spend most of your time. So very quickly on the control center, what you can see is that there's not a lot of information, and that's on purpose. As I mentioned before, we try to be very selective with what we show. In the control center, you have a feed essentially, so it matters where you are in the feed, and you have a card-based system. Each card is either an issue here in blue or an insight in orange. So what's the difference? An issue is something that you need to pay attention to right now, something that's affecting your environment right now. An insight is something that is useful to know, such as a prediction. So let me go through each one. In a card like this one, for instance, what you can see is that things are written in English, right? So you can read first that there's a critical problem. It touches the infrastructure and the application. And you can read there's an application performance issue detected. And the subtext typically starts giving you a clue as to what has been clustered together. New relic, low updates detected combined with high CPU and availability problems. It comes from 4 data sources: Ansible, New Relic, Pingdom, and AWS. And it's already been pushed to through 2 notification channels, Slack and VictorOps, at this particular time. You have the ability to store. You can collaborate through this menu. If you click on it, what you get on the right are 2 things. First, you get supporting evidence, things that are correlated, that instead of you having to gather all the data from different tools, you have here in one place. If you click on every single one of those incidents, then you get the detail, the same detail that you get through your monitoring tools. The second thing that you see is what we call SAM's diagnosis. So SAM is SignifAI Augmented Member. And SAM, at this particular stage, this is minute, 25 of your implementation, pulls from a knowledge base that comes from us and from the community. So you can read about a diagnosis that gives you a definition, what's happening, some recommendation, how to fix it. And one thing that you'll notice is that here there's a thumbs up and thumbs down. it's very possible that what we are showing you at any point in time is not relevant to you, and that's great. We want to be a great team member, and so we want your feedback. This allows us to make sure that we get better and better over time and more dependable and more accurate by learning from what you think of the information we put in front of you. So you can take just a quick second to give a thumbs up, and that's great. You reinforce the fact that Sam, is providing you relevant information. If not, you just give us a thumbs down, and next time you won't see that information. So at this particular time, you're still collaborating and getting through the issue. You notice that we have taken you very close to an answer. It's not an answer just yet because we're still learning about your system, and it could be that it's an issue that is still not documented in the system. But the moment you've fixed the issue, you can go back to a quick process of documentation. So it's always difficult to convince someone to write a postmortems or a run book. But if you have just a few seconds, you can answer those questions, and that's really great reinforcement learning for us. And I'll tell you how it's useful for the future. The first is we ask you what the root cause of the issue was. And it's a fixed list. Just click out of a menu. What systems were involved? You can just say, do you use any scripts? If you used any script, you can drop the file here. And finally, do you want to add anything else? Here, you can just put some free text. It could be some observations. You can copy and paste something that was on email, on Slack, or HipChat. It's free text. The reason it's important, it's because the next time around, so we correlate in essentially all this knowledge with a set of technical conditions. And if those conditions happen to reoccur in the future, some diagnosis here will be informed by your knowledge base. So the reason it's important to document is because the next time around, you will have right in front of you information on who worked on solving a similar issue in the past, what they documented, what scripts were used, and it makes it a lot faster to essentially just go and fix an issue. So that's why it's very, very useful to get that done right away when it's still fresh, and it only takes a few seconds. Let's go through an insight. So an insight can be of different nature. The first, it could be a prediction. And here, we try to err on the side of accuracy. The scope of our prediction is fixed at this stage. We try to be precise, and so things like the fact that 5 of your hosts in clustershopping.com will run out of memory in 4 days, easy for us to predict. It may not be something that you had spotted before, and so you can just give us some quick feedback as well. So is this relevant? Yes or no? We can give you a fact. There is currently high utilization of Amazon EC2 instances. This is correct. What I want to know if it's relevant for you or not. And so you can just give us that feedback. It could be a weekly summary or a monthly summary. Those summaries are actually useful because if, let's say that you've had a similar issue occur 3 or 4 times in the same week or same month, it may be related to an underlying problem related to the architecture. So looking at summaries, it's actually always useful. Or an insight could simply be an update status on one of your external dependencies, because that's something that we also track. So all this so far has been shown to you based on logic that we've put into the system or that comes from the community. You haven't configured the system itself. And that's great. You can just leverage all those correlations and predictions without having to configure much, and just it will make your job already a lot easier. Now, let's say that you have some very, very specific things that you want to implement because you had a particularly difficult issue 2 weeks ago. You want to make sure it doesn't happen again, or you have specific concerns. What we'll ask you to do is to go to the Decisions tab, the last tab. In the decisions tab, you have the logic that we put into the system. We call it Sam's decision. You can read what it means, the description. You can read the syntax. We don't give you access to that particular decision. You cannot modify it, but you can give us feedback on it. But what we'd like is for you to set up your own decision. And so here, hopefully, you'll be able to motivate yourself to go and set up a decision. You have the ability to name it. You can describe exactly what you want to implement. And then we give you an abstraction layer to an expert system. The expert system gives you access to 100% of the data that you've given SignifAI access to. So it could be everything. So you can correlate data coming from any data source to data coming from any other data source. But it's all drop-down menu. It's presented as a if this, then that. If you're familiar with the expert system, you know that the structure is when, then, but typically there's a lot more familiarity with the if this, then that approach. So you can select, for instance, what this says here is like this particular data source. I want to see if there's a z-score with an anomaly. Everything is coming from a drop-down menu. If that is the case, then I want this first action, which is different levels of notification per notification channel. Then I want to verify another condition. Is there an anomaly, or you can have N or 50% of the host name that starts with VA, depending on your internal nomenclature, you can have a semantic condition, have a measure of less than 90% to a metric that you define. Then I want this type of notification. Whatever it is that you want to do, typically you express it in, I want to prevent like a particular issue to happen. Typically you need to define the conditions that led to a specific metric in your system to have an abnormal behavior or behavior that is not up to your expectations. If you express it in this way, what is the metric that I want to affect? And what are the things that I want to spot that could lead to that metric being unaffected? And what does that metric being affected mean? Could mean memory leak. It could mean an application problem of this particular nature. If you just take a few minutes to express it in this way, then it's very easy to codify it into a decision. And that's how you control what's going on in the control center and make it more relevant to your particular environment. The last thing that I want to touch upon is the fact that the logic that goes into control center is constantly evolving. It's evolving because we continuously put some expertise. We're continuously adding decisions. You are continuously adding some expertise and putting decisions. You're also providing feedback, not just you, but some of the decisions that run across different environments and other companies. We're getting feedback across the board, and so we're better able to calibrate what goes into every single environment. We also learn from other environments' best practices. If someone is particularly successful with a particular decision, we can determine whether that decision will be relevant to your environment. It's the same code base, same tools, same volume of data, this number of conditions that will make that happen. And then we can suggest to you to implement additional decisions. So we're constantly evolving this to make sure that we are more and more relevant, and then we stay dependable, and that we evolve just like your learning, your team, and your system evolve. So that's a very high level demo of where we are today. And we look forward to you becoming a SignifAI team member.
All right, thank you, JP, and thank you for joining us. So the next steps, if you haven't already done so, head on over to signifai.io to learn more about the machine intelligence platform, and also sign up for a free trial. As JP showed you, it's pretty painless. You're within 20 minutes of getting to your first insight. So we hope to see you online. Thanks, everyone, and have a good rest of your day.